Okay, so here are the notes on graphing polynomials. So this is sort of the culminating thing here. All the stuff we're going to be doing in this section here is something that you've already sort of done. We're just going to now do it with polynomials. So graphing polynomials is very similar to graphing parabolas in that you're going to be using a graphing calculator, as you can see, to find virtually all of the information. So some basic things here that we're going to have to find. The first one here is what is called end behavior. Okay, end behavior here, and basically you're describing how the graph behaves on the right side and the left side. So if you see here, you'll see it's always going to be in this format of f of x. This arrow means approaches, so f of x approaches in positive infinity as x goes to infinity. So we're always going to look at, okay, so what happens when x goes this way forever, and what happens when x goes this way forever? Because it's a polynomial, oftentimes you'll see it go like opposite. Sometimes it'll go the same direction in both left and right, but oftentimes it will go in opposite directions. So here you have the function going positive infinity means up, so going up as x goes to positive infinity, and over here as x goes to negative infinity, the graph goes down or to negative infinity. So if you just remember that up, this direction is positive infinity, this direction is negative infinity, then that should cover most of the bases here. So you look here too, so with this graph, as it goes to the right, it goes up, so that's positive infinity. As it goes left to negative infinity, it actually also goes up. So that's why f of x goes to infinity as well. So we're going to learn how to write those. The other thing that we will have to find is down here is what is called local max and local minimum. So basically, since the graph has curves to it, you have parts of it that dip down and come back up. So similar to parabolas, you can find these local max and local min by using your graphing calculator. So the reason why this is important, oftentimes in real life, you may be looking at a particular set of data, whether it's stock prices or something like that, and you might want to find, where was it its lowest and where was it its highest. So we look at these local maximums, but these you can find using your graphing calculator the same way you found vertex with parabolas. So the first thing we're going to do here is down here at number 5. We're going to, it does say to identify the local max and local min, but also we're going to look at the end behavior. So the first thing we need to do, obviously, is put this in our graphing calculator. So x to the third plus 3x squared plus 2x. And so we can look at this in our graphing calculator. Now on the paper here, it has it all zoomed in. But basically, when we're trying to find local max and local min, looking between in these ranges here, the local max would be the highest point on a hump. So when we're looking at these, we're looking at the local max would be right here. That's the highest point within this. You're looking at the humps basically. So it's the highest point of that hump, and then the local minimum would be somewhere over here, the lowest point of that dip. And when you're finding local maximum, that's essentially what you're doing. So to get this a little bit closer and easier to see, I'm going to zoom in here. And I'm going to zoom into right there. So we can see a little bit closer to, now it's weird that doesn't look the same. Did I type something in wrong? x to the third plus 3x squared. Oh, plus 2, not 2x. Like, that doesn't look the same. Okay, there we go. Now we just need to make this. Sorry, got a little carried away here. Oh, still doesn't work. I need to go to like, let's go to 10. There you go. So I wanted something that we can look at the graph similar to the one that's right here. So local max and min is basically finding the top and the bottom of this little bump here. So similar to the way we found vertex, you'll go to second and trace, and then since we're finding local maximum first, and you could do either one, but I'm going to find local max first. We go to maximum, and so you remember what we did. You want to go just a little bit left of that, hit enter, so that you get like the little bar, and then go a little bit right of it, enter, and enter a third time, and that will give us our local max, which we write the coordinate. So the local max is, I'll just write it right above the dot here, -2, 6. It's a -2. On the test or a quiz or something like that, you'll have a spot for this. We don't really have any spots here, so I just wrote it on the graph. -2, 6. Now I'm going to find the local min. Again, same way that you found vertex. You want to go to a little bit left of that bottom and then a little bit right of that bottom. Hit enter, and then a third time there. And so that -1.7955 e to the -6, anytime you see e like that, e to the negative number is going to be 0. It's just a calculator having a rounding error. So it's supposed to be 0. So x is 0 and y is 2. So there's my local max and min. And so now when we want to write end behavior, so how it is written as, so we write it as f of x approaches. So when we're talking about on this side, f of x, since the graph goes up like this, then we know that as f of x approaches infinity. If it were going down, then it would be negative infinity. Since it's going up, we're going to go the positive infinity as x approaches infinity as well. And then on the other side, now we're looking at this side here. This side's going down. So we'd write f of x approaches negative infinity as x approaches negative infinity as well. What that is saying is that as we go this way forever, it goes up. So as we go this way forever, it goes to positive infinity. This way, as we go this way forever, so as x approaches negative infinity, it goes down forever. So f of x approaches negative infinity as well. The notation is going to be kind of hard to get used to, but we'll put in some templates in there to make it a little bit easier to understand. So the other thing we're going to add here is what are called intervals. And so when we look at an equation, so let's look at C. I know these notes don't really ask what I'm going to be asking, because like for C, we're going to do a few things, not just describe the end behavior. So let's look at this question here. And so I'm gonna type this one in. Oops. So I have 2x to the third plus x squared plus 3x plus 2. And so when I graph this one, well, that's a weird one. Let's not use that one, because that one doesn't have a dip in the beginning. So it doesn't have a local max or a min. So I don't want to use that one. Let's try this one down here, since we have to graph them anyways. So this has got an x to the 5th in there. Now it doesn't really matter when you're putting this in your graphing calculator, the order. So I'll just do it how it's written, plus 3x to the 5th minus x. And so there we go. We get a little zoom 6. Oops, zoom 6. And then I'm going to zoom in here. There we go. So now we should be able to find local max and local min. And so here's a list of everything we're going to have to find. So we're going to have to find local max and local min. So I'm going to say L max and L min. These will be coordinates, local max, local min. The other thing we'll have to find is end behavior. Okay. So let's find those right now. Let me change colors. So local max and local min, again, second calc. And so let's find the max first. So max is over here, so I just make the cursor a little bit left of it and then a little bit right of it. Enter. And so there's my local max. Looks like negative 0.6 and 0.7, negative 0.6 and 0.7 is my local max. And then my local min, let's go to minimum and put a little bit left of that bottom, a little bit, oh, doesn't really matter, but a little bit right of that. Enter. So my local minimum here is looks like 0.37 and negative 0.21. And so that would be on my local max and local min. So end behavior, this is similar to the other one. So f of x, I'm going to just write it here, f of x. Since it's going up, f of x will approach infinity as x approaches infinity. So it's going up as the graph's going right. And the other side, f of x approaches negative infinity. So it goes down as x approaches negative infinity as well. So a couple things we want to do too is we want to put all these points on the graph. So I have a local max at negative 0.6 and 0.7. This is going to be really close here. Negative 0.6 and 0.7, so probably right there. I'm gonna make this. Let's do every 4 is 1. That's negative 1, 1, 2. Just to make this a little bit easier to read. So 0.6 actually, local max of negative 0.6 will actually be here, and 0.7, so that'd be somewhere right there. Doesn't need to be exact. And local min was 0.37 and negative 0.21. So somewhere right there. The other thing we're going to have to find, and you're not going to get graphs that are so close, like zoomed in like this, but the other thing we're going to have to do here is we're also going to have to find our x-intercepts. So that means all of the zeros. And so it looks like here that you have 1, 2, 3 zeros. It crosses the x-axis 3 different times. So we're going to have all of those as well. So remember I told you this was like a culminating thing. So we're going to look at zeros. And so just like the vertex or the max and min, so here's my x-intercept right there. So I want to place it a little bit left of that and then a little bit right of it. And so I have an x-intercept of negative 0.89. I'm just going to put commas. And then second, 0. I have another one. Looks like it goes right through 0, 0, but let's check. So put it on the right side of that. Enter. Yep, 0, 0. So x-intercept is at 0. And then another one over here as it crosses right there. Oh, going fast. So it crosses at 0.6 as well. And so those are my x-intercepts. And so on here, I want to put those on there. Negative 0.89, somewhere right here. And it crosses at 0. and then it also crosses at negative 0.6. Not negative 0.6, 0.6. Did I put negative 0.6? Oh, it is 0.6. Okay, so the goal here, when you put your local max and your min and your x-intercepts, is you have all these points that you can then draw your graph. So I'm going to draw my graph now, connecting all these dots. And that's the goal here, is to be able to do this. Now there's one more piece we're going to add to this. So I'm going to go ahead and just use one of these equations. So we're going to use this bottom one. I'm not going to evaluate. It says to evaluate. I'm not going to evaluate. I'm just going to use it to do my graphing piece here. So I'm going to graph this, and we'll use this graph up here to graph it. So I know we're going all over the place with these notes, but I'm trying to be concise here. So I have negative x to the third minus 2x squared minus 3x plus 4. So we can graph this. And so let's see, this one might be a little bit more normal. No, it's not normal. It doesn't have all the x-intercepts here. Try to think of another one I can use here. Let's see. You know what? I'm just going to change. I'm going to change a number here. So let's go to okay. So I just changed that to a 6, and this should work. So I changed this to a 6. No worries. Just working on the fly here. That is a negative 6x squared, I think. That's the one I changed. Yep. And so now we have a little bit more of a contrasting graph. And this is kind of what yours will look like on a test or a quiz, something that's a little bit more obvious. So we need to find a bunch of things. Local, max, local, min. We also need to find your end behavior. We also need to find x-intercepts. So we're going to go ahead and do that. So local max and local min, second. So let's find the minimum first, since it's the one that's on the left. So I need to be on the left side. There it is. I know I can't see the bottom, but it doesn't really matter. See, my cursor is on the left side, and then I'll just wait till it comes up on the right side. There you go. Enter, enter again. And so it gives me a local minimum of negative 3.7 and negative 16.4. I'm going to change colors in this. And and these are backwards because that's actually the local minimum. There you go. Let's find the local max. So this one, I just want to be here somewhere on the left side, and then that went fast. Holy cow! And then somewhere here on the right side. Enter. Looks like it's negative 0.27. And 4.39. End behavior. So this is actually going to work opposite, because here we have as x goes to infinity, or as x goes all the way to the right, the graph actually goes down. So you want to write f of x approaches negative. Oops. No, wrong thing. F of x approaches negative infinity as x approaches positive infinity. So as it goes to the right, the function actually goes down, and then the other one, f of x approaches positive infinity. So it's going up as x goes left, approaches negative infinity. So the graph is going down. That's what this means here. The graph is going down as it's going to the right. The function is going up as it's going to the left. And that's what that means. X-intercepts, we got 3 of them. So again, these kind of take a while to do, but you know how to do everything. I'm going to start from left and work left to right. So I'm going to go left side of it, right side of it, enter. So negative 5.29. Oops. And then second trace, 0, another one, left of it, right of it. There it is, negative 1.29. And the last one, by the way, you only have to do one of these. It takes enough time just to do one here. And right of it, enter, and it looks like 0.58. Now, you thought you were done, right? There's more we need to add. So the next thing here is we're going to look at increasing interval and decreasing interval. Now this one's easy. There's not really anything to do because you just have to look at because it is increasing between vertex and it is decreasing between vertices. There's not really any math that needs to be done here. But basically, where is it increasing? Where is it decreasing? So we know that the graph, if you look at the graph on my screen on the left here, the graph is decreasing from negative. It goes forever, so negative infinity, but it's decreasing all the way to the first vertex, the local min. So it is decreasing all the way to the first one there, which is our local min. Then it starts to increase. So what we do, how we write that, is it's decreasing from negative infinity all the way to the first local minimum. We only look at the x values, by the way. Negative 3.7. And it's decreasing from the last vertex to infinity. So we're looking at from the last max, so negative 0.27. I wish I could, show you on here. I can't use my cursor on the other side, the other screen. Negative 0.27 to positive infinity. So maybe I can show you with the cursor on here. Let me see, trace. So what we see here, let me explain this. It is decreasing all the way, decreasing until it reaches that local minimum. And then you'll see that look at the y value. It starts increasing. Okay, and then it's decreasing again after here. And so after here, you'll see it start to decrease forever. And so that's why we write over here that it starts from negative infinity and decreases all the way till the local min. There, it starts to rise. So that's what we're going to put here. Once it's done rising, then it goes back down after that local maximum. So what we're going to do here now is put it's increasing between the two vertices. So it's increasing between these 2 points. So we just have to put those 2 points. Negative 0.37. Oh, negative 3.7. 0.7. Negative 3.7 to negative 0.27. And there you go. It'll be increasing between those two vertices. So there's a lot there. I recommend looking at the stuff on big ideas, but also look at the review and watch the how-to video on the review as I'll go through more of these. So I hope that helped somewhat, and we'll do some more of these before we take our test. All right.